This is a new transmitter that I built from scratch. It has got 8 channels and an OLED display to show voltage and transmission values. It can control almost any drone and provide a long range with its upgraded transmission module. It uses S-Bus protocol for its connection. Costing me around $40, that's roughly around 4,000 rupees, and the commercial version cost around 7k to 8k rupees for the same power. The interesting part, this tiny LoRa module inside. It's made for long range IoT communications or telemetry devices, so I thought to try it in a RC transmitter. In my previous design, if you have remembered, the connection kept on breaking as we were using normal NRF modules. And now we will test how good these module works. So the first step is to design the CAD model. Since this time we are not using this bigger display, so it will be a more compact design. So after designing it for some time, I landed on this. So it has got 2 joysticks, 3 toggle switches, 1 potentiometer. This is the mini OLED display. This is the charging port of it, and this is the power button. And this is its exploded view. And you can see it has got all the mounts for the parts. And this part will hold all the electronics. To get the 3D files, you can visit the mechninja.com. You'll find all the STL files, wiring diagram, code and instruction manual. For printing, I'll use the Core XY printer which we designed in the previous video. Okay, so I have sliced it and it's showing approx 15 hours, and this is the preview of it. So these are the printer settings I am using. So wall thickness is 1.2 mm, infill is 20%, material is 220 degrees Celsius, and the speed is 60 mm per second. And I am using support of zigzag pattern. Now let's print it. Everything is printing in PLA. The case is completed and it looks good. In fact, all the parts are looking good. A big thanks to Reyax for providing these RYLR998 LoRa module used in this project. They also sent over the RYLS135 USB to UART transceiver. It makes programming the LoRa modules and various UART based devices quick and easy. You can find all these modules and many other products on the website. The link is in the description. So here's the challenge we faced. These modules are built for long range communications but not speed. So at longer distance, even a single message can take up to a second to read. And on top of that, we are using a half duplex LoRa module, which means it can either transmit or receive data at one time, not both simultaneously. So because of this limitation, we can't add built-in telemetry to send drone data back to the transmitter. So for now, we'll only focus on building the transmitter. This 1.3-inch display will show us the voltage as well as the channel PWM value. I'm using 3 toggle switches and 1 potentiometer for extra control. So earlier we used these analog joysticks, but this time we'll be using these Hall effect joystick to check whether they improve their performance or not. All the electronic components are linked in the description below. I mounted everything on the electronics plate and wired everything according to the wiring diagram. Assembling everything is a bit tricky, but it's quite manageable. Now let's do the coding. So insert the USB while pressing the boot button. A window will pop up, just paste the code to it and that's it. And to verify the code, just plug in the USB and okay, now it's showing all the values, that means it's correct. Use 18650 lithium ion cell and its voltage is 3.7 volt. Okay. So after inserting the cell, a new problem arises. Let me show you. If we will check individual cell voltage, 3.5 and this one is 3.58. That's roughly around 7 point something, right? But now if you will see in the display, it's showing 6.32. So there's a difference of approx 0.6 volt. Now let's check the BMS voltage. So the B minus and B plus is showing 7.21 and that's okay. But the P minus and P plus is showing a different voltage and that is 5.74. So it's not correct. So we are going to replace this BMS and then test it. Okay, so we have replaced the charging module and BMS. Now let's test the voltage. So B minus and B plus is giving 7.21, P minus and P plus 7.22, and you can see the battery voltage is also now similar to 7.17. Now that's accurate. So these were faulty. Now let's put on the knob and check the transmitter. Okay, so it's completed now and looks really good. And on comparing it with this pocket, both are of almost same size. In fact, this one is a little smaller. Now let's assemble the receiver. So for the receiver, I'll use the same Pico and AMS 1117. Since the combo is ready, let's verify it before testing. I'll use this basic Pixox setup. Now let's connect it. Okay, so it's connected now. That's why you are seeing all these green bars. Otherwise, it would be blank. Now let's check the channels. Okay, so it's working. So this one is channel 1 and you can see the pitch is moving up and down. And this is channel 2, channel 3, channel 4, 8, this is also working. Okay, so everything is working now. Let's test it on a drone. As you have seen during the test flight, the drone wasn't able to maintain its altitude and was giving certain jerky movements. So at first we thought that it was because of these fluctuating values, but later on we found out that it was because of this Pixox barometer. It was giving false reading. So now we have to change the drone. So I have a couple of drones with me and I'll choose this CUAV drone. Okay, so if you can see the speed, it's 4.8 to 5.4 meter per second and the temperature is 38 something. So as soon as I lost its sight after 250 meters, I brought it back using return to land feature. So we took a test flight and it was really exhausting to test at 40 degrees Celsius. But as the thing, it just worked perfectly, like zero disconnects the entire time. Have you ever had that moment where something works better than you expected? That was this. And the NRF transmitter we built before, that thing was disconnecting sometimes. It was a little annoying but okay. And one more thing, these analog joysticks perform better than the ones, the Hall effect one used in this transmitter. I don't know why, but the drone was more stable in this one. So we can go with this. And the range, these modules are insane, like we are talking in kilometers. And I have talked to the Reyax team and they explained me that these are half duplex modules and I have to use an ACK mechanism to get the data back from the drone to the transmitter, which I will do later. So if anyone had worked with LoRa modules before, let me know in the comment section, like I want to see if you have had similar experiences. And honestly, I'm blown away by how much good it is as compared to the NRF module. And if you are thinking to build a long range RC system, then you can grab the Reyax module, the link is in the description. And if you want to build one like this, everything is on my website, themechninja.com. Now here's my question, guys. What are the challenges you faced while designing these RC systems? Like, I'm curious to know what are the problems you all are facing. And thanks for watching. If this was helpful, then please like and subscribe to my channel for more videos like this. Alright, see you later in the next one.